two different characteristics or two different aspects. So the first column will have the first aspect. Then you've got, now here, you've got two rows. Okay? Those two rows, they belong to the same aspect, just that we've got colors here. So we've got red and black. And then here you've got spades, and then you've got others. That has to do with a deck of cards. Alright? Then, now I'm sure you are familiar with this. You can, if you can have, okay, if it's red and it's a spade, you can't have a card which is a spade and then it's red. You know that, eh?
Yes, sir.
So that's why we've got this 0 here. Others that are red, they are 26. Then the black ones, the spades, there are about 13 of them because they are black in color. And then the others are also 13. Right? Then you've got the totals. So the total of the spades is 13. Total of the others is 39. Then if you add the red ones, obviously we are excluding the jokers here, by the way. Right? So the total in the deck of cards is going to be what? 52. Okay?
So there are red spades, not deck of cards.
There's diamonds and hearts.
Oh, shit!
Okay.
Oh, yeah.
All right. So
Clearly not a gun.
the first question, please pay attention. The first question says, determine the probability that a randomly selected card is black. Now, when you are dealing with this, first thing, you need to determine your NS, the total in the sample space. The total in the sample space, you got your totals where they converge. That's where your totals are. So this 52 here, that's your NS. That's the total in the sample space. But how many cards are black? What? 26. So the probability of getting a card, of picking a card which is black, so we are here now, by the way. Right. So we are doing B1. Okay, I put 1. So this will be P black. Okay. So this one now is going to be equal to 26 over 52. And that would be a half. Okay? I think what I should do, need to joke at this page. Yeah. Not to do it there. This one thing I know about this. Okay. So we're here. So I've done the first one. Then the second one, which is that the probability of getting a spade. So we've got spades here. The total is what? 13. So it will be P spade. That would be 13 over 52, which is what? The contingency table is the easiest among the three of them. That's the Venn diagram, tree diagram, and the contingency table. Right? Then, okay, then we move on to that. A black one and a spade. Now, in probability, the word end means intersection. So we want a black one and it's also what? A spade. That would be what? 13. So here it will be P, the black one, and it's also a spade. So it will be 13 over. Yeah. And then a black or a spade. Now the word or in probability means add. So we add all the black ones, they are 26. All the spades, they are what? 13. Okay? So let's go to the next page. So we are now here. Okay, what happens is that sometimes I took a screenshot of this. If I try to load it here, that I will not be able to adjust that. Well, I think I've got time, I can do it. but sometimes it won't work properly. It can backfire. Let's do it that way. So we're doing number 4. So it will be P, black or spade. Okay. So we add that and that. So we get 39 over what? 52. And this will be 3 over 4. Okay. And then a red or a spade. So to be safe or we have to add. How many red we have? 26. How many spades? 13. Okay. How many spades do we have? So we have got number 5. So that will be P, red or a spade. So that will be 26 plus 13. So we get 39 over 52, which is 304. Do you have a question? Huh? Or what's your question? Please ask.
So how does black forest in your heart?
A blade or a spade?
The spade is black.
So we find out that you to be added
You see here, it says the probability that a card is red. Okay?
No, it's the previous question.
In this one here,
Yes.
a black or a spade.
The spade is black.
Okay, but is it the only one which is
and clubs. So there's 13 spades, there's 13 clubs, and there's 26 black clubs. But how are we having 39 black spades?
Oh, I get what you mean. It makes lots of sense. Right? So we have got 26 that are black. The spades are also black, so means if I took 39 like what I did, means I will counted them twice.
Yes.
Okay. Okay. Let's fix that. It makes sense. So that's number 4. It shows that people are following what's happening. Yeah, it makes sense.
So that's the wrong question.
So that's the right answer.
Okay. This one is. Okay. Let me just check out everything. Okay. So that would be, but here, it makes a lot of sense because this stage they are actually black, right? Therefore, the total has to be 26. It will be over 52. And that will be okay. Then, yeah, this one here is fine.
26 plus 13, 39.
Which one I took out? I took out number 4 for this one here. Because those spades are also black. So you're going to end up counting them twice, like how I did initially. Okay. Alright. Then number 2 now says, are the events, can I have your attention? Are the events card is red and card is spade mutually exclusive? Now here we'll go back to grade 10 a little bit. Okay. So remember when I spoke about mutually exclusive events, I said, so this is now number 2, probability of A or B is equal to the probability of A plus the probability of what? Of B. If the two events are mutually exclusive. So what is PA or B? So in this case now, we are dealing with I'm going to be more specific based on the question. So it will be P black or spade. Sorry, red rather. P red or spade. So it will be P red or spade. That. Did we get that probability here? Red or what? Or spade. So that probability is 3 over 4. Right, so we got this. Then, what is the probability of getting a red? Right, a red, that's a half. So it's going to be a half. What is the probability of getting a spade? And that will be a what? A quarter. Then, if we put the 3 over 4 on the right hand side, so from here now, we say 3 over 4 will be equal to a half plus a quarter, right? I'm sure you can agree with me that that's a 3/4. This is also 3/4. So what this means is that the two events are what? Therefore, the two events are mutually exclusive. Okay.
So the working out is the reason.
Yes, yes. The working out is your motivation. Then you need to write a conclusion. Okay, your conclusion must be based on the working out. Right? Then the next question is now on independent events. This is the most common one now. The most common question that you will get on the contingency table. If you do a lot of practice, you are going to encounter a question which will ask you to prove that the two events are independent or not. So with independent events, if you have been paying attention, let me do this on a new page. Right? Recently, I introduced the multiplication law of probabilities. So if two events are independent, the probability of A and B will be equal to the probability of A times the probability of B. Okay? So, now on a contingency table, the way it ends, you see here, it says, are the events card is black and card is spade independent? Okay? What is the intersection of spades and black is this one? That would be P black and what? Spade. Okay, so let's write it down. So probability of, let me use a different color. So the probability of getting a card which is black is also a spade. This is going to be equal to 13 over 52, which is a quarter. Then,
This 26. What's this 26?
don't confuse or and end. And means intersection.
No.
Black and spade. Let's go back. Black and spade. We did it already. Right? Black and spade. It's there. It's a quarter. Okay. So the probability of getting the card which is black. What is it equal to? Huh? Okay, that will be 26 over 52, which is half. So this is the half. What is the probability of getting a spade? What? It's a quarter. Okay? Then we substitute now. Where there is and here, we are going to put a quarter. This should be equal to a half and 1/4. Now, unfortunately, these two are not equal. So we can conclude here and say, therefore, the two events are not independent. Independent. Okay. Right. We have got 18 minutes.